everybody. We are going to solve a new problem. A football player releases a ball with the initial conditions shown in the figure. Determine the radius of curvature rho of the path and the time rate change of the speed, that is acceleration, at time when it is 1 second of flight and when this ball spent 2 seconds in the air, where initial time is 0 from the release from the quarters hand. Okay, so in this problem you can see that this is a simple problem from projectile motion. This player is throwing a ball with the initial speed 24 meter per second and theta is given, the angle of launch is given to us, that is 35 degree. Okay, so let's try to solve this problem. First of all, we will make a diagram. So in this we will assume that this ball is going to be launched in this way. The initial speed is our 24 meter per second and the angle is 35 degree. Okay, now before we solve, we will try to understand this problem. Okay, so as you know that this ball will fly, it will go up into the air and it will reach to the maximum point and then it will fall on the ground. Okay, so as per the problem, we have to find the radius of curvature, okay, and acceleration. At what time? When time is 1 second, okay, and time is 2 second. Similarly, we have to find acceleration at both time 1 second and time 2 second. Okay, so when we have a problem where we have to find radius of curvature, guys, then we have to remember that we have our one popular formula, or you can say that we are using this many times, that an is equal to v square upon rho. Okay, an is acceleration in the normal direction and v is the velocity and rho is the radius of curvature. So if we can find the velocity at time 1 second and the acceleration in normal direction at t is equal to 1 second, then we can find the radius of curvature. So guys, let's try to find the velocity first, and from the velocity we will try to find the acceleration. But before we go this, okay, let's talk about one important concept here. Let's see, this is the maximum height, okay, of a projectile. If we have to draw vector diagram before the maximum height, so it will look like this. For any point, this is our Vx and this is Vy, and you know that Vx is always same during the flight, so you can write V naught cos theta, and for Vy is equal to Vy naught sine theta, but Vy will keep changing at each point of flight. Okay, and let's talk about the second concept, that when the ball will cross the maximum height, the vector diagram will change. Vx will be the same, but Vy will working towards downward direction. I hope you got this concept. Now let's talk about the third concept we apply in projectile motion, that the gravitational acceleration or total acceleration is always working in a downward direction for any point. Okay, So you can see that total acceleration g is always working downward direction for any point during the flight. Now we will use these concepts and then we will solve the problem. So as I said that we will solve these values, but first we have to know where is the ball at first second and where the ball will go in the second. So to know this exactly, first we have to find what will be the time when it will reach the maximum height. Okay, so you know that we can use this formula Vy equal to Vy naught minus gt, and also you know the concept that maximum height it is Vy component is equal to 0. So we will apply this concept here and we will put Vy is equal to 0 is equal to Vy naught minus gt, and here we will solve it. Vy naught is how much? That is V naught sine theta. So we will write V naught sine theta minus g and t. Now in this equation you can see that V naught is given to us, theta is given to us, we know the g, we can find t. So let's put the values here. 0 is equal to V naught is 24 sine 35, g is 9.81 multiplied by t. So here is our answer. T is equal to 1.403 second at maximum height. Okay, so it means that when ball will take 1.403 second to reach the maximum height. Okay, from this answer we are clear that ball will be before the maximum height at 1 second. Okay, and ball will be after the maximum height after the 2 second. Okay, this will make our task easier to make our vector diagram. Okay, so now let's solve for time 1 second. Vx is equal to V naught cos theta, that is 24 multiplied by cos 35 is equal to 19.66 meter per second, and Vy is equal to V naught sine 35. Okay, so sine 35 is equal to 3.96 meter per second. Okay, okay, for time 1 second we will solve. Okay, we will try to find the velocity what at the time t is equal to 1 second. So in this case I will write the formula for Vx is equal to V naught cos theta. Okay, that is 24 cos 35 is equal to 19.66 meter per second. Okay, now let's see for Vy formula. We will apply Vy is equal to Vy naught, okay, minus gt. Okay, now we will see that what is Vy naught. It is 24 sine 35 minus g, and time is how much we are solving for 1 second, so I will write 1. Okay, the answer will be 3.96 meter per second. Now you saw that you have calculated Vx and Vy. Okay, so you can easily calculate V at t is equal to 1 second is equal to Vx square plus Vy square. Okay, so put these values of 19.66 meter per second and 3.96 meter per second. So you can put the values 19.66 square plus 3.96 square is equal to how much? It is 20.1 meter per second. So you have easily calculated the velocity at time 1 second. Secondly, we have to find the radius of curvature, and to find the radius of curvature we need to find the acceleration. Okay, so now let's move on and let's find acceleration. Okay, now this is a big question, how we can calculate acceleration. Okay, so I will make a vector diagram of the velocities and the acceleration, and then I will explain you how to calculate acceleration. So suppose this is the maximum point I'm making. Suppose this is the t1. Okay, so in this case I will make axis, that is this is our Vx. Okay, and this is Vy. Okay, these are the two vectors at time is equal to 1 second, and this is a resultant vector v which you have calculated now. Okay, so finding acceleration we need certain information from the this diagram. Okay, in the starting of this problem I said the total acceleration is always working downward direction at any point. This, so this total acceleration is equal to gravitational acceleration. Okay, at any point. Similarly, the AG is working in a downward direction. Okay, and this will be G, 9.81 meter per second square. Okay guys, we have G, and I mean AG I will write. So AG is equal to AN plus AT. Okay, so where is AT and where is AN? You know that if you can find AN, you can find the radius of curvature. Okay, so as we know from the curvilinear motion that AT, the acceleration in tangential direction, will work is always collinear to the velocity. It means that you can see in this picture it will be on the same line of the velocity. Okay, this line. Okay, I will highlight this, it will be on this line. Okay, but the point is that what will be the direction? Either our acceleration is going in upward direction or in downward direction, AT. So you know that when projectile is going towards or moving upward direction, its velocity is decreasing, and at its maximum point Vy becomes 0. Okay, it means that acceleration is decreasing. So once acceleration in tangential direction will decrease, the AT will be in the direction of opposite to the velocity. So this will be our AT vector. Okay, guys, now we have two vectors, AT and AG. To find AN, we need certain angle theta. Okay, if we will get the theta, we can easily find AN. Now, without the value of AN, let's make AN vector, because we have AT and AG, we can make AN. You know that AN is always perpendicular to the tangential line. Okay, so in this case, you can see that AT, we can make a 90-degree line to the AT, and this will be our normal. Normal is always 90 degree to the tangential line. So guys, now we have AN, AT and AG diagram, but we do not have exact values. Okay, so let's see how we can solve. If we can find this theta, we can find AN, because we have already AG is given to us. Okay, to find this theta, if we carefully notice this problem, we will see this A theta, or this theta, is equal to this angle. Okay, by geometry. So it's very good for us that we can easily find this angle theta, tan inverse of what, Vy and Vx, because we have already these information given to us. Okay, Vy and Vx is already we have calculated. Okay, so from this we will calculate this theta. Okay, moving on, here I will write theta. This is pen. Theta is equal to tan inverse Vy upon Vx. Put the values you just calculated, and the angle is 11.38 degree. Okay, now based on this theta, our task becomes easier, because this theta is known and we can easily calculate AN. Okay, so based on this, we have AG is already known, it is 9.81 meter per second square. So we can find AN is equal to AG multiplied by cos theta, and that will be your 9.81 multiplied by cos, and this theta is we just calculated here, it is 11.38. Okay, so we got the information, we will calculate this value AN. So we got the value for AN is 9.61 meter per second square. Now we are going to calculate our most important value, that is, we know that AN is equal to V square upon rho. Okay, and not to forget that we are solving for time at 1 second. Okay, so we have already calculated the value for velocity, and we have the value for AN now, so we can find the radius of curvature when the ball will reach at time 1 second. Okay, so for this purpose I'm going to put the values 9.617 for AN, the velocity is 20.1 meter per second, and the value of G is uh, sorry, and the radius of curvature for the radius of curvature is 41.8 meter. This is our answer. Okay, now we have already calculated AN. Okay, and we know the AG, so we can calculate AT very easily. Okay, so you can use two vectors either, or you can just use the angle. In terms of angle, I will tell you AT will be equal to minus G sine 11.38. Okay, this is how you calculate AT. There is a other way, then you can write AG is equal to AN square plus AT square. So you can use this formula to also calculate the AT. Now we have to move, or we have to solve for the when ball will reach at the time will be 2 seconds. So at 2 seconds we now let's solve for the time 2 second. Okay, it Vx, and you know that Vx remains constant V naught cos theta is a launch angle. Okay, not to confuse. So it was already calculated by ourselves. So it is 19.66 meter per second, and you know that Vy is not constant, it depends upon Vy naught minus gt. Okay, so I will put the values for Vy naught is 24 sine 35 launch angle minus g multiplied by time 2 second. Okay, here it is 2 second. So we will get the value for Vy, that is minus 5.85 meter per second. You know what is interesting here, that the value for this Vy is in minus. Okay, so it means that the velocity vector will be for Vy is going downward direction. Okay, so let's make a velocity vector, so this will make our task easy. So I will assume that on the there is a point, and this is the path, and this point is time 2 second. Okay, so for this purpose I will make a first Vx, this is always in x direction and remains constant. Vy will be in the Vy direction, negative, so it's going downward direction, and it is also not a fixed quantity. Okay, now let's make this, as you know that this is our x-axis and this is y-axis. Okay, and we have already calculated, or now we can calculate Vy, V, it will be under root Vx square plus Vy square. So we will put these two values here. Okay, and the answer will be 25.5 meter per second. So this vector, okay, is here. This V is just calculated, it is 20.5 meter per second. So what I'm going to do, I'm going to make the resultant vector V. Okay, and it will be somewhere here. So guys, we have information Vx, Vy and V. Okay, so we can use to find this angle. Suppose I will say this is a beta angle. Okay, so we can find this beta angle easily using tan inverse Vy upon Vx. Okay, put these values, tan inverse, I will do the step by step. 5.85 upon Vx is how much? It is 19.66. So here you get 16.58 degree. Okay, not the radian. So beta is known to us. Okay, so now we have to move to calculate acceleration, and I explained the last time that the acceleration, the total acceleration is working downward direction ag. Okay, so in this way we can also calculate or make the at and an. So first of all let's know where is at. Okay, acceleration in the tangential direction. Okay, now we know that the acceleration in the tangential direction will be on the collinear to the velocity vector. Okay, now since we this velocity is increasing, it means that at is increasing. Okay, so the at direction will be also in the same direction of the velocity. Okay, now you have at. How you will find the an vector acceleration in the normal direction? You know that an is always perpendicular to the at, so you can make a 90-degree to this, and this will be your an. Okay guys, so now we have an and at vectors, but we do not know exactly the angle. So as from this geometry, this beta is also equal to the here beta. Okay, this will be the same angle. Okay, so in this case we can use this angle to find an and ag. So using the same concept here, we can find ag. Okay, we can find an. So we can write an is equal to v square upon rho. Okay, I will bring rho here. I will write v square upon an. Okay, v square is how much? 20.5 meter per second square. Here we will make this velocity is 20.5 meter per second, and we will make a square, and an will be ag multiplied by how much? This will be cos beta. Okay, so you can put the values here. Okay, and you can calculate the value of rho is 20.5 square, or I will just write the answer here. Okay, so from this equation, from here I will get the value of the rho, 44.8 meter. In the same way, once you have ag, you have an, then you can also easily find at. Okay, by two ways as I explained earlier. Okay, here we can apply the angle, and we can write ag multiplied by sine beta, and that is our answer will be 2.80 meter per second square. I hope you liked it. Okay, and if you have any suggestion, let me know in the comment. Thank you very much. Have a nice time.